Hey, let's take a look at your LT3 assignment. Don't forget your name. Can't give you credit if you don't put your name on it. On question number 2, we got this graph here, so let's make a slope triangle. That is, notice my graph goes up 3 and it goes over 6. So our slope then is 3 over 6. 6. I get a little dirt in my pencil. Equals 1/2. Okay, number 3, we don't have a graph. So at this point, I think we'll use our slope formula. So we're going to say y2 minus y1 over x2 minus x1. So what we're going to do is we're going to subtract our y's and subtract our x's. Notice I labeled those xy, xy. What you call the first one, what you call the second one is relative. It doesn't matter as long as you work them in the same way. So I'll call my second point, I'm going to call negative 14. So I'm going to say negative 14 minus 10 all over 15 minus a negative 3. Well, negative 14 minus 10 is negative 24. Remember, when you subtract a negative, you actually add it. So 15 plus 3 is 18. And I notice 24 over 18 reduces. I can reduce them both by 6. And you get negative 4 over 3, which I wrote in red for you, in case you can't read my chicken scratch. And there's our answer. Now, on question number 4, be careful, because people will look at this and say, oh, after 1 hour, the cost is $38, so therefore the hourly rate is $38 per hour, which is incorrect. Notice they charge a setup fee. So that $38 includes our setup fee. So what we're going to do is we're going to do this like our rate of change. My independent variable is my x, so I think I'll just use the first 2 points. So what I'm going to do then to find my rate of change is I'm going to go 3 minus 1 over 64. Let's try that again. I just did it backwards, didn't I? Dang it. We'll do that again. Because my time is my independent variable, so that goes in my denominator. I'm going to have 3 minus 1 in my denominator. Almost made the same mistake you guys made. And then 64 minus 38 would go in my numerator. Now we subtract 64 minus 38. 14 minus 8 is 6, so I get 26 over 2, which is 13. Now, however, we're doing the hourly rental fee. Please answer in a complete sentence. So it costs $13 per hour to rent the bounce house. That's a rate of change. Remember, rate of change has the units in it. Now, if we keep on going to question 5, we're on the same lines here. It says, a frozen custard shop sells a medium shape with 2 mix-ins for $5.07. So I can represent that as 2 comma 507 because the cost depends on how many mix-ins we have. Where a medium shake with 5 mix-ins sells for $7.14. So now to find this answer, we're just going to use our slope formula, rate of change formula again. Maybe I'll write that down this time. y2 minus y1 over x2 minus x1. xy, xy. So I'll go 714 minus 507. And I'll divide that by 5 minus 2. Well, we'll go 714 minus 507. Let's find that calculator on here. And let me see. There we go. 714 minus 507 gives us $2.07. And that's a little over 3, isn't it? So then I'll divide my answer by 3. Oops, I got to type my answer in there. Then divided by 3 gives me 69 cents. I think I had 68 cents there. We'll change that to 69 cents. There we go. So each mix-in costs 69 cents. Now, to find the rate of change of an equation, we need to substitute some numbers in here. We need to make two ordered pairs just like we did in number 5. I like 0 for the first one because notice if I replace x with 0, 0 plus 5 is 5. Now we'll pick another point. Notice I have a fraction here. I don't want a fraction because that's a whole number. If this was a fraction, it might be different. But I want a whole number here. So what I'm going to do is I'm going to put in 3 for x. Maybe I'll show my work here too. So what happens is I'm going to take negative 2/3 times 3. That was such a pretty 3 too, and it disappeared. Oh. Let's try erasing that, write that again. Okay. Times 3 plus 5. Notice my 3's reduced, so I really get negative 2 plus 5, which turns out to be positive 3. So now I can use my slope formula. Subtract my y's over subtract my x's. So we're going to say 3 minus 5 all over 3 minus 0. 3 minus 5 is negative 2. 3 minus 0 is 3, and we get the answer in red, which is negative 2/3. Now, on the next one, it's kind of hard not to get fractions here. So let's just do it with the fractions. But I will kind of give you a hint to keep the same denominator. So I like 0 again. So if I put in 0 for x, this whole part is gone. My answer is negative 7/5. Let's put in 1 for x. And once again, I'll show my work. 4/5 times 1 minus 7/5. So that's 4/5 minus 7/5, which is negative 3/5. So then I get negative 3/5 right here. So now, let's use our slope formula. So we're going to go y2 minus y1 over x2 minus x1. So we're going to say negative 3/5 minus a negative 7/5 equals over 1 minus 0. Well, remember, when you subtract a negative, you get 4/5 over 1. A number divided by 1 is always just the number, so we get 4/5. Now, did you find this a simpler way? Maybe you remembered something from last year? We'll be learning about that later on. Now, if we take a look at number 8, the formula for vertical lines, slope breaks down for vertical lines because the difference in our x value is 0. You can't divide by 0. If you take any number divided by 0, it's undefined. That's why it doesn't work. That's from our seminar. Okay, number 9. Oh, we got a lot going on here. So what happens here, I want to write an expression for D that passes through A, B, C, D if the slope is 1/2. Well, remember, slope is y2 minus y1 over x2 minus x1. On this problem, we know the slope is 1/2. And then remember, it goes xy, xy. So let's do that. We'll say d minus b all over c minus a. Now, what do you do to get d by itself? That goes back to what we did in the first chapter. Well, first thing I'm going to do, I'm going to multiply by my denominator. So I multiply both sides by c minus a. Notice on the right-hand side, the c minus a is reduced. On the left-hand side, I'm just going to put c minus a all over 2 equals d minus b. Then to solve for d, I'm going to add b to both sides. So I'm going to say c minus a all over 2 plus b equals d. That is the answer I prefer. If you want to get a common denominator, that's where we get a common denominator, and the answer in red is they just put 2b here, 2b over 2, which just reduces to plain old b. And number 11, I want to explain how the rate of change and slope are related and how to find the slope of a line. Well, slope and rate of change are really the same thing. We can use slope to describe the rate of change. The only difference is rate of change is going to have some units because it's the ratio of the dependent to the dependent, where slope is the difference of the y's divided by the difference in the x's. There are no units with slope because they're always the same, so they reduce out.